All right, let's go ahead and tackle some more u substitution problems. I kind of gave you the u's for the homework last night, but I want to talk about how would you decide what a u is? Well, you choose a u such that when you take the derivative of it, this thing right here exists in the equation. And you kind of start to get a handle on it. Usually this thing right here is being raised to a power, or is under a square root, or is inside a trig function. So I just wanted to give you a heads up on that. Next thing I want to talk about is if you see an exponent with a trig function, I want you to rewrite it. This sine to the 4x is actually the same thing as sine of x to the 4th power. And so I want you to rewrite it like that. And so I just said previously that we want to be able to take u and then take the derivative of it and get something in the equation. Well, that's not really helpful in this problem because you can take the derivative of cosine and get a negative sign. You can take the derivative of sine and get a cosine. So what we really have to think about in this problem is what is being raised to a power, or what's under a radical, or that's kind of how your mind should be thinking. And in this case, our u is going to be a sine x because it's being raised to that power. Now the derivative of sine is going to be cosine x dx. And I'm going to see if I have a match. Looks like I do. So I can rewrite this whole thing as u to the 4th, and cosine x dx is a perfect match, so I can write du here. I'm going to go ahead and integrate that, so that's going to give me u to the 5th over 5 plus c, and of course we need to substitute back in, and this is going to be sine of x to the 5th over 5 plus c. And then we want to rewrite that as sine to the 5th x over 5 plus c. There we go. Okay, let's go ahead and try to tackle this one. Again, remember for your u, you want to be able to take the derivative of it so that you see that answer in your problem, or you see something really close to it. So in this case, we're actually going to choose x squared right here. And then, that's oftentimes the case if we have something in parentheses. And I take the derivative of it and I get a 2x. And don't forget your dx. Now the problem is I have a 7x dx and I don't have a 2x dx. So what I need to do is I need to multiply this 7 by 2/7, because then my 7s would cancel and I'd be left with 2. So if I multiply, and I'm going to put on the outside so you can see it. If I multiply by 2/7, see again the 7s would cancel. I'd be just left with 2. If I multiply by 2/7 there, I'm going to have to multiply by 7/2 out here so that I'm not changing the integral. All right, now at this point, when I multiply this times a 7x, I do in fact get what I want, which is going to be that 2x sine of x squared dx. And so since I have a match of 2x dx, I'm going to rewrite this whole integral as a sine of u, because remember this time x squared is u, and then I'm going to have du because I have this match, the 2x and the dx. See the 2x and the dx. All right, so let's go ahead and integrate this. So I'm going to guess cosine u. The derivative of cosine is not sine, it's a negative sign, so I've got to remember my negative, but I also have to bring down that 7/2. All right, last step is going to be to substitute my x squared in. So that gives me a negative 7/2 cosine of x squared plus c. There you go. And just a quick note for some of you might have had this question, sine squared x is equal to sine x quantity squared. But if I have sine of x squared, that is actually just equal to a sine of quantity x squared. Okay, so you see the difference between the two. It's important where you see where the two exists. All right, hope that clarified things for some people. All right, in this particular problem, it actually doesn't really matter which one we choose to be u, but I like to just avoid negatives, so I'm going to do u equals sine x and du equals cosine x dx. And I'm even going to make this easier for myself and pull out the 12. So I'm going to rewrite this as 12 on the outside, sine x cosine x dx. And I have a perfect match here. And I also have a perfect match with the sine x. So I'm going to have 12 integral of u, because u and sine x are the same. And then the cosine x dx becomes du. So we have to integrate this, and don't panic, this is just u to the first power. So this is going to be u squared over 2. I'm going to drop down that 12. So simplifying this, I get a 6u squared plus c, plugging in my u value here, which is in terms of x, I have a 6 sine x quantity squared plus c. And I do want to rewrite that as a 6 sine squared x plus c. All right, let's try another one. In this particular problem here, again, I've mentioned this on the first slide, that you usually, general rule, not always, want to set your u equal to the thing that's being raised to the power. So in this case, 5x plus 2. du is going to be equal to 5 dx, which means I would want to multiply, because I want a 5 here and not a 3, I'd want to multiply by 5/3. Which means I would multiply by 3/5 on the outside. So let me simplify this. Again, remember my 3's cancel, so I'm left with my 3/5 stays on the outside. But now I just have a 5 there. And then it's going to be a dx. So that 5 stays there, and I've got the dx. And at this point, I have perfect matches. So I'm going to have a 3/5 integral of a u cubed and then a du. Integrating this, I get u to the 4th over 4. I drop down my 3/5. Don't forget my plus c. Let's see if we can reduce this at all. This is going to be 3u to the 4th over 20. And I don't think that reduces. Next thing I'm going to do is plug my u back in terms of x. So I'm going to have 3 parentheses 5x plus 2. Don't forget to my power of 4 all over 20. All right, I want to do one more and then that's it. So this one, the thing I want you to think about is, what can I take the derivative of and get an answer right here that exists in the problem? Well, if you choose tangent of x, you will get a secant squared x dx, which is perfectly listed right here. So let's go ahead and pull out the 4. You can always pull out a constant if you want. Okay, and now I'm just going to go ahead and change my tangent x to a u and my secant squared x dx to a du. So this will just be simply a u du. Integrating the u, remember it's to the first power, I get a u squared over 2, drop down the 4, plus c. So now I'm going to have a 4 divided by 2 reduce to be just a 2u squared plus c. And last thing that we do is we take this and we plug it in. So I get a 2 tangent x quantity squared plus c. And don't forget, if I'm squaring the quantity of a trig function, this is going to be written as a 2 tan squared x plus c. Thanks for watching, everyone.